Hello Year 10s, this is lesson 3 in the 1.4 booklet on domestic electricity. Last lesson we had a look at kilowatt hours, which are the units that we use for electricity. So we need to make sure that we know all about time. You ought to know that there are 60 minutes in 1 hour. And many of us recognise that 15 minutes is a quarter of an hour, or 0.25 of an hour. Now, question 1, work out what 10 minutes would be in hours. Now, I've had this before. I've had pupils say, yeah, it's 0.1 hours. It's a tenth of an hour. No, it's not. That is totally wrong. To work out what 10 minutes would be as a fraction of 1 hour, it is 10 minutes divided by 60 minutes. And that gives you a very strange answer indeed. 10 divided by 60 gives you 0.16 reoccurring hours. So you do definitely need to be using a calculator here, and obviously on the clock face 10 minutes would go to there. For each of the following clocks, write down the number of minutes indicated and then the answer to number 1, but in hours. So let's try, I don't know, that one there. "25 minutes. What would that be as a fraction of 1 hour? Show your workings. Is 25 divided by 60, and that gives us 0.416 reoccurring hours. So that was question 2. Question 3. Give that one a go. Question 4. That is 6 minutes. And then question 5. You do that yourself. You choose any place on the clock face and work out what that would be as a fraction of an hour. So I'm going to go back. Let's have a look at this. Question 3. Question 3. How many minutes is that? That'll be 45 minutes. What is 45 minutes as a fraction of an hour? 45 divided by 60 gives me 0.75 hours. Of course, 45 minutes is 3/4 of an hour. 3/4, put that into your calculator, you'll get that answer. 0.75 hours is 3/4 of an hour. Number 4, this was 6 minutes, wasn't it? 6 divided by 60 gives us 0.1 hours, a tenth of an hour. And you had a go at question 5. Okay. This TV is in standby mode at the moment. When an electrical device is in standby mode, it still uses power. it's still on. It's still transferring electrical energy, and it costs you money to do that. The only way to stop it using any power at all is to switch it off at the wall socket. Now, in a previous booklet, we've already seen that energy is power times time, right? That's that equation here. This equation can have other units, and from this we can work out the cost of the electricity used. So we've got exactly the same equation, energy equals power times time, is exactly the same, but we're just going to use slightly different units. Now the units that we're going to use, the energy, the electrical energy is measured in kilowatt hours. The power is measured in kilowatts, and the time we're going to measure in hours. That's why we had to be able to convert between minutes and hours. It's something that you should be able to do. So let's try and work out the cost of using an electrical appliance. So a cooker has a power rating of 3 kilowatts. Great. It's been switched on for 18 hours. We should be able to calculate the amount of energy that has been transferred. You need both the power and the time to work out the amount of energy transferred. So, energy equals power times time. Marvellous. Always write the equation down. Then it's the workings. The power is in kilowatts, that's 3. Multiplied by the time, that's 18. 3 times 18 equals 54 units of electricity. But now what we want to do is work out the cost. Well, 1 kilowatt hour costs 12p, but we've got 54 units of electricity. So the cost equals 54 units multiplied by 12p, and that gives us 648 pence. Divide that by 100 and you get £6.48. Easy. Now, I like this one. This makes me laugh, right? Put your money where your mouth or eyes are. How much money do you think it will cost to have a TV on for? Well, over the years, I've asked pupils in the classroom, what's the sort of average amount of time that you are viewing TV or screen time? And that includes playing games and stuff like that. And over the years, it's gone steadily up and up and up and up and up. It is not unknown now for pupils to literally get back home from school and literally stare at a screen for 8 hours. It's just madness. There's something going wrong there. That's not healthy. Anyway, I reckon that screen time on average is going to be about 3.5 hours a day, right? How much money do you think it would cost to have a TV on for 3.5 hours? How much is it going to cost? Now, I'd like you to write down your prediction. Do it in pence and then do it in pounds. Now, I've had some fun times with pupils before, because pupils will write down, it sounds very reasonable, £5 or 500 pence. Okay, seems reasonable, it's only £5. But then what I say to them is, you are telling me that a TV switched on for 3.5 hours is going to cost you £5 every day. And then you start saying, okay, £5 multiplied by 365 days in a year. You are telling me that to watch TV for 3 hours a day is going to cost you 5 times 365, which is £1,825, and that's just for the TV. That's not with the fridge that's on 24/7 and all your lights and everything else. I tell you what, I'd like to sell you lot electricity. I'd make a fortune. Now, the power rating. We've done this before. The power rating of a 5-foot TV is 87 watts. Now, energy is power times time, but I've got to convert those watts into kilowatts, and to do that, I take my 87 and I divide it by 1000, and so I get that the time is 3.5. The total amount of units, kilowatt hours used, are those two numbers multiplied together, and you get this. Not even a half a kilowatt hour. Now, if the electricity was charged at 12p per kilowatt hour, then to work out the cost, it is 0.3045 multiplied by 12p gives me, to one decimal place, 3.7 pence. That is nowhere near £5. That's just ridiculous. So the cost of electricity is a little bit lower than you might think. Now, let's have a look at this. We've got a toaster, and we've got the information that we need. It is 700 watts. That's its power. 3 minutes the toaster is on for. The cost per unit of electricity, 14p. I wonder, could you do question 1A and B before I do it? Here we go. Energy is power times time. The power is 700, but it needs to be turned into kilowatts, divided by 1000. You get 0.7 multiplied by the time. The time is 3 minutes, but you need to convert that into hours. So it's 3 divided by 60. And so that's going to equal 0.7 multiplied by 0.05. And that equals... So that was the 3 divided by 60 was the 0.05, okay? So now I times those two numbers together, 0.7 multiplied by 0.05, and I get 0.035 kilowatt hours of electricity is needed to turn bread into toast once. Okay? Now, the total cost. The cost is going to be the units used, multiplied by the cost per unit. So the units used was this value here, 0.035 35 multiplied by the cost is 14p, that's here. And when I multiply these two numbers together, I'm going to get this here, 0.49p. It's not even half a p. That will be the end of the lesson today.